Well, in our law of sines, we have what's called the ambiguous case, and that occurs when I know two sides and the angle is not included. And what happens is we have several different outcomes or several different possible outcomes that can happen depending on the length of h. So here I have a graphic that kind of depicts the different outcomes that could happen when I have this particular scenario. So if we have one triangle, we have a setup that looks like something similar to an isosceles triangle. But in the case over here, we could have either a side that doesn't end up touching. So in other words, we don't end up with the missing side we need for a triangle that we're trying to solve for. Or we could end up having two triangles, as in this case, where one triangle is almost embedded inside of the other. So we have one triangle, no triangle, or two triangles that are possible outcomes when we have this kind of ambiguous case scenario. So let's look at an example that utilizes this idea. In this first one, we have triangle ABC. We know angle A, we know side A, as well as side B. So that's what we're going to look at, and we want to find all of the angles and sides of this triangle. So the law of sines says I can use the law of sines ratio as long as I know a side and its corresponding angle. So we're going to use that part first. So I have side A divided by the sine of angle A would be equal to side B divided by the sine of angle B. So side A is 81, angle A is 43, so we take the sine of it. Side B is 62 divided by the sine of B. And when we cross multiply here, sine B is what we're trying to isolate. So we have sine B that I'm going to multiply by 81. I'll expand all of this out for you the first time. And we're going to multiply that by the other diagonal, which would be 62 times the sine of 43. So in order to get sine B by itself, I would have to divide both sides by 81. And I end up with sine B is equal to 62 times the sine of 43 divided by 81. Now I can do all of this right here in my calculator, and when I do this multiplication, I find out that sine B is equal to 0.5220. In order to solve for this angle B, I now have to take the inverse sine, because remember that's how we do that on our calculators. So, but when I do that, I have two possible angles that I'm going to get, right? Because when I take the sine of some angle and get back a positive value, I have angles that are positive over here in the first quadrant, as well as angles that are positive for sine in the second quadrant. So I have two possible angle choices that could come out of this. So let's look at what's going to happen here. On my calculator, I'm going to take the inverse sine for the first angle. I'm going to put it in as inverse sine of 0.5220. And when I do, I get something that's around 31 degrees. Now the second angle that I would have, so that's this angle over here in quadrant 1. The second angle, which is going to occur over here in quadrant 2, is going to have to be 180 degrees minus the 31, and that gives me 149 degrees. So these are the two possible angles that I could have for this angle B. But I need to know which one do I choose. Let's look at the large angle that we have as a possibility right here. If I have a triangle made up of that would include this angle B, and it is equal to 149 degrees. I also already know that I have angle A, which is equal to 43 degrees. And the sum of these two angles, if I were to add these two angles up already, is equal to 192 degrees already. So two angles out of the three that are possible in a triangle are already giving me 192 degrees. And I can only have 180 degrees total in my triangle. So this angle right here is too large. And we do that by taking that angle, adding it to the angle we already know, and kind of evaluating it. So 31 degrees is the angle that we're going to use in this particular case. Now that I know, and let's just kind of summarize what we know again down here. Angle A was equal to 43 degrees. Angle B is equal to 31. Let me just make sure. Yep. Angle B is equal to 31. I know side A is equal to 81. And side B is equal to 62. So what do I need to find? I need to find angle C. Now angle C is going to come from the fact that 180 degrees total for a triangle minus the 43 minus the 31, giving me a total of 106 degrees for angle C. Now that I know angle C, I can use the law of sines again. And the law of sines say that I just need to have a side and its angle ratio. So let's just pick angle A. So we'll say side A over the sine of A is equal to side C over the sine of C. Filling in A, we get 81 over the sine of 43 equals side C, because that's what I'm looking for, over the sine of 106. So we're going to solve this for C, and when we cross multiply we would get C is equal to 81 times the sine of 106 divided by the sine of 43, and you should find out that that value is going to be equal to 114.2. And that's how we can use the ambiguous case when we end up finding just one triangle. So remember, if these are our choices up here, this example was a scenario of this type of a triangle.